Number 9. All right. First, graph these points. All right, but we want the equation for the perpendicular bisector. So what does that mean? That means it's going to be a line that's perpendicular to the green segment and cuts it right in half, bisecting it. So if we drew that line, it would be somewhere around here, and it would be perpendicular. Well, if it's the bisector, it goes through the green segment's midpoint. For the midpoint, we will take the average of the x coordinates, -4 and 6, and after the comma, we want the middle of the y's. We'll take the average of the y coordinates, 5 and -5. So our midpoint is 1, 0. Now we need to find the slope of the red line. Remember, to find the equation of a line in point-slope form, we'll need to know a point on that line, which we have with the red point 1, 0, and we need the slope of the red line. Well, how will we find the slope of the red line? We know it's perpendicular to the green one. So if we know the slope of the green segment, then we can determine the slope of the red perpendicular bisector. So the slope of the green segment, which is the slope of segment AB, is the rise over the run. So to find the rise, we'll subtract the y's. Y's up in the skies. -5 minus 5. And we'll take the x values, 6 and -4, and subtract them down below. The slope of the green segment is -10 over 10, which is -1. But we need the slope of the red line. So the slope that is perpendicular to this will be the opposite reciprocal. And what is the opposite reciprocal of -1 over +1? It would be a positive 1 over 1. All right, now that we know a point on the red perpendicular bisector of the green segment, and we know the slope, we can write its equation in point-slope form. Remember, the template is this. The slope will go here, and the x value will get placed in the template near the x, and the y value will get placed in the template near the y. Or in other words, y equals x minus 1. And that is the equation of the red perpendicular bisector of the segment with the given endpoints.